This is Sindhuja. I'm from Hyderabad. I'm going to explain what my homework for. Yeah, first problem is nearly mind bunch problem. This is the command line I have used to execute my problem. So, how many hits did it take like to mismatch did you find? It is asked like for 10K it took like 6372, for 100K 9523, and for 1,000,000 21356 it's approximately. And how much time did it take like for hits are like for 10K is 13919, for 100K 1356, and for 1,000,000 1321 seconds approximately. And for the total entire data subject is like it took like approximately 435T0757 seconds. So here number of hits increased like according to the data set because the data set is larger. So like for 10K like 100K it is going on increasing, and the second is also same as the data set is long and hits are increasing, time will also increase approximately. And when it comes to part B, this is also like this command I have used, and for 10K 100K and 1,000,000 it took like 0 hits, and seconds are like it is very less because hits are 0, it took like less time like these are the seconds. As hits are 0 it takes time is also less. Yeah, that's all. And for problem B, yeah, this is blast. This is the command line I have used to execute. And for like how many hits with up to two mismatches did you find? For 10K it is like 5946, for 100K 4086, and for million for 1,000,000 is 75462. Yeah, these are the hits approximately, and the time it take like to search for that hits are like for 10K 781, for 100K 7907, and for million is like 80205 seconds approximately. Yeah, here I found this 5946, and remaining I had calculated that here also as the it increases like hits increases according to the data set is larger, so time also increases approximately. Yeah, and for entire data subject, it as usual it takes much time, so this is the time it took. And for part B, like hits are like 0, so hits are 0 it took very less time, and this is like less than part A also, it took less seconds. So because when you compare that and I mean from question 1 part B and question 2 part B, here in the two algorithms, Needleman Finch algorithm has time complexity big of n square, like so that it takes this is very slow with a large type of data set, but like with the but this is like when comes to what we say a problem B, in this here it is like it scanning like 4 power 11 possible, so it takes like weeks since there are number of dynamic comparisons, but when it comes to Blatt's algorithm it takes size of 11 primarily searches. So yeah, it is better than the that one. Yeah, so when it comes to my code explanation, yeah, this is my code. So here we are using namespace, and these are all the macros for arithmetic loop construct. This is my class container, I mean like abstract class for container types. And this is like genome to store the genome data. All this I have used here public. And this is like to insert if anything array to resize necessary, then when we are using this. And this is like to generate the like random character. And this method is like to start position, like I mean to get random start position from the genome data. And this is like to read the genome data. In that we have written many function. This is to get the buffer, get the inserting the data, and here to like compare 32 characters. We have used this one. So we have taken loop 32. So it like 32 times. So 32 characters. Here also we used like a sample class. Yeah. When it comes to here, we have used it for, this is like Needleman Wunsch function. This is like to find the mismatches for hits. That's what we have used all this here. And also it is search function to find the best match. We have used it here. And when it comes to here, this is like to handle, this is the class function to handle hash functions. This is all this. And this is queries BL. This is also like asked to take that particular class. So we have taken that in that, and this is like to convert string to integer hash. Yeah, that's all this is about. And this is like to search function, search the string in the hash table. That's all this is. And when comes to yeah, genome.cpp, this is like header files, this namespace, and this is used to read line from the file to file from the buffer, and also to read the data. This is like to start frequent times in the execution time, and this is like to check the correct number of arguments are provided or not. And also we have taken argument one of one is to read the genome data based on the provided argument. We have used this. We have used switch case here so that we can study like switch case one and case two. Case one here is for first one like Needleman one sequence. So I have used here 100 first so that I can calculate for remaining because it's a large data set. And this is second one. Mm, yeah. That is this, and here we have differences in results are like Needleman once provided precise, but computationally this is like expensive sequence alignments, while Blast is like it is faster when compared to the Needleman, and also it matches using hashing and local alignment. And specific bugs are like improper random data handling in genome data, insufficient memory management. Yeah, all these are bugs and unoptimized search algorithms. And optimization, like highlighting, is like pre-computing base powers of hash function in queries BL that is mentioned, significantly enhanced hash table performance and also reduced collision rates. Yeah, this is my explanation. Thank you.